Okay, good day everyone. So we will be having a review about diesel engine construction and components. So basic construction components. Okay, first we have here the bed plate. So it is the foundation. It is rigid enough to support the rest of the engine, and it holds the crankshaft, the bearing housing, and it should be flexible enough to hug and sag with the foundation plate to which it is attached and which forms part of the ship structure. Next, we have the A-frames or frames or A-frames. So it is the load carrying part of an engine. So it may include parts such as the cylinder block, the base, the sump, and end plates. So in two-stroke engines, they are sometimes known as A-frames. So it is like a letter A. And then on top of the A-frames, we have the engine block or entablature. So it is the part of the engine frame that supports the engine cylinder liners, cylinder heads, and cylinder block, which incorporates the scavenged airspace in two-stroke engines. Okay, so we also have the cylinder liner, which forms the cylindrical space in which the piston reciprocates. So, dyan dumadaan yung ating piston. The piston moves inside the cylinder liner, moves up and down. So, also in the liner, we have a jacket cooling. So, we have here a cooling water. We have leakage telltales, in which you can see if there will be leakages in the O-rings. So, there will be water coming out from these holes in here. And we have here the intake ports for two-stroke engine. We have here the intake ports in which the scavenged air will go inside these intake ports. And also we have here the drill for the lubrication, or for our cylinder lubrication. So our cylinder lubricator. So the oil will go inside these drills. Inside this drill. Okay. And then this part of the liner, part of the liner is thickened, since this is where the combustion will take place. So this is the combustion chamber. So since the pressure here is higher, so the metal also in here is thickened in the liner, thicker than the rest, and there are tangential drillings so that the cooling water can penetrate deeper inside deeper in the liner. Okay. Okay, that's it. Next, we have the pistons. So this is the piston number 12, and then this is the piston rod. So since this is a two-stroke engine, so we have a piston rod in here. And then the inside of the piston rod is hollow, so that the oil can go inside and cool down the piston. So the pistons oscillate inside the cylinder liner, compressing air, and receives force from the expanding gas during combustion. So pistons are cooled either using water or the crankcase oil. So this is the crankcase oil. Okay, so the piston comprises of the crown, this blue one, the color blue, that is the crown, and the orange one is the skirt. This green one is the piston rod. Okay, so the piston rod has a hollow tube, so oil goes inside, cooling down the piston crown, and then through these nozzles, so oil will spray here, and then the hot oil will go out of the piston. Okay, so as you can see, there are pistons with longer skirt than others. So there are pistons with short skirt. So pistons with short skirt usually is used in two-stroke engine, um, since there is a crosshead that absorbs the side force due to the rotation of the crankshaft. So the connecting rod um, will be pushed or pulled to the left or to the right, so the crosshead will absorb the force. While in four-stroke engine, usually there is no crosshead that will absorb the force side sideward force of the piston. So the piston will be having a longer skirt. So this is the one that will absorb the side force from the piston to the liner. So the piston rod is utilized to carry the oil to and from the piston. So we have nozzle plates and nozzles for cooling. We have also here the piston rings, 1, 2, 3, 4 piston ring and 1 scraper ring. 1, 2, 3 piston ring and 1 scraper ring here. So piston rings seal the gas space by expanding outwards due to the gas pressure acting behind them, while the oil scraper rings spread the lubricating oil up and down the cylinder liner and transfer heat to the liner walls. Okay, we have here a connecting rod. It is fitted between the crosshead and the crankshaft. It transmits the firing force and together with the crankshaft converts the reciprocating motion to a rotary motion. So oil to lubricate the crankpin bearing is supplied down a drilling in the conrod from the crosshead. So may mga butas din dyan sa gitna yan para makapasok yung ating lubrication. Okay, next we have the crosshead. So these are the parts of the crosshead we have here. So ito yung crosshead. This is the crosshead. We have here, this one is the crosshead. This is the connecting rod. So crosshead, we have crosshead sleepers. And then we have the guides, so that the crosshead sleepers will slide on these guides or crosshead guides. And we have the crosshead pin to hold them. So the crosshead connects the piston rod to the connecting rod. On either side of the crosshead pin are mounted the crosshead sleepers. So the sleepers run up and down in the crosshead guides as the piston and rod are reciprocating and prevent the top of the connecting rod from moving sideways. Okay, next we have the stuffing box. So the stuffing box prevents the lubricating oil from being carried upward and also not allowing the compressed air from the scavenged space to leak into the crankcase or in the bottom. So the stuffing box casing, which can be split vertically as shown in the photo, this one, so it can be split vertically, contains a series of scraper rings. So these are the scraper rings, 1, 2, 3, 4, 5, 6, 7, and then this is the spring, scraper rings and sealing rings, which are each made up of 3 or 4 segments. So this we have here the sealing ring, so that oil from the top oil from the bottom of the crankcase will not go up. So we have here scraper rings, and then we have also a piston rod drain tank. So if ever there will be something that will be scraped inside, so we'll go to the drain tank. And at the top we have also another sealing ring, so that the air inside in the scavenge port or in the scavenge space will not go to the bottom, to the crankcase, to prevent explosion. Okay, next we have the crankshaft. So the crankshaft is the main rotating component of a diesel engine. So look how big this crankshaft is. So this is the man, and this is the crankshaft So this is a big engine. So it converts the reciprocating movement of the piston to a rotational movement. So there are different built for crankshaft. We have fully built crankshaft, we have semi-built crankshaft, and we have assembled crankshaft. So usually assembled crankshaft. Usually we have fully built crankshaft, the big ones, small ones, and you can do assembled or semi-built for big ones. Next we have the camshaft. So the camshaft carries the cams which operate the fuel pumps and exhaust valves. So because these operate once every cycle of the engine, the camshaft of a 2-stroke engine rotates at the same speed as the crankshaft. While for a 4-stroke engine, it rotates, one motion of the crankshaft is 2 rotation of the engine. So it is also very important that the fuel pump and exhaust valve operate at exactly the right time. So the camshaft is driven by the crankshaft. So 2 methods are used to drive the camshaft via the crankshaft. So these are the gear drive and the chain drive. So here we can see there is a chain tightener so that you can adjust the chain of the engine. Okay, here we have a explosion relief valve, and here we have a crankcase door. Okay, this is for 4-stroke engine. So this is the cylinder head of the 4-stroke engine. We have 2 intake valve and 2 exhaust valve with a fuel injector in here, and here we can put something here for starting air or for the test cock. Then we have 4 we have here so this is for the exhaust. Yeah. Okay, cylinder head. So in the cylinder head we have here the intake exhaust valves. We have here the valve seats in which the valve will take a seat. We have here the retainer spring. We have the retainer lock. So in the cylinder with the intake valve, it opens at the proper time to let in air and fuel, or for air and fuel for gasoline type engine or for carburetor type engine. So exhaust valve open at the proper time to release the exhaust. We have the valve cover that protects the valve. The valve spring keeps dirt out and lubricating oil in. We have valve spring, this one. The valve spring helps keep the valve shut. Depending on the design, a valve spring may comprise 1 or 2 different springs. So this is the valve spring or retainer spring, valve spring, and we have the valve spring retainer. So as its name suggests, the spring retainer is the part that helps to maintain the spring position. So this one. So we have here the spring, valve spring, and then we have the valve spring retainer, this one. So this is put on top of this one, and we have the retainer lock to hold this one. Okay, valve spring retainer with the retainer lock and the valve seal. So this one is the valve seal, this one. Let's go back. So the valve spring retainer is the part that helps to maintain the spring position. The retainer lock is a part that lies between the spring retainer and the tip of the valve to hold the lock in place and other components intact. And the valve seal mounted the valve stem and just under the spring. The valve seal prevents cylinder head leaks. It keeps oil from getting into the intake and exhaust passageways and ensures the proper working of the cylinder head parts. We have the valve guide. The valve guide simply guides the valve. Valve guides are the metal piece, usually iron or bronze. While we have valve seat, this part provides a seat that the valve makes contact with to form a seal. We have the spring seat. For some cylinder heads contain a spring seat, but not all. Valve lifter and rocker arm. So valve lifter is a component that opens and closes a valve. It is worked by the camshaft. So in an OHC cylinder head, the lifter pushes against the valve directly. So the lifter used on a pushrod engine actuates the rocker arm, which in turn opens the valve. Valve lifters are used on the intake and exhaust valve. So these are the rocker arm. So we have here here is the rocker arm that pushes, and then here we have a push rod that push the rocker arm. So the one that pushes the push rod is the camshaft, or the cam. Okay, we have here a crankshaft. We have here the flywheel. So in this flywheel there is a gear, in which in this gear the starting motor will be will drive the crankshaft, this one. But for larger engines, we only have turning gear that will be geared in the flywheel. Okay, here we have big end bearings. And then holding the big end bearings is the big end caps, that one. Okay, we have the main bearings. So from the center of the crankshaft we have the main bearings, and this is the we have the crankshaft journal, the center, and then protecting it from scratch is the main bearings. And then the main bearings is main bearings. And then we have here the one connecting the crankshaft journal and the connecting rod journal is the crank web, or balance, or these webs, this one. And then since these webs also have a counterweight in them, so they are sometimes called as the balancing webs. For two-stroke engines, so they don't have counterweight, so they only have the webs. Okay, and then we have here the bearing for the connecting rod. So connecting rod bearings. This is the connecting rod bearings. And then this is the connecting rod journal. So on the other end of the crankshaft, we have here the vibration damper. So this one will be the one that will absorb or dampen the vibration in the crankshaft during rotation. And you can also equip a fan driving pulley. So for some engines who uses a fan, so they can put a pulley in here. Next, we have the crankcase doors. So these, when properly designed, are made of about 3 mm thick steel with a dished aspect and are capable of withstanding 12 bar pressure. So they are securely dogged with a rubber seal arrangement. So for inspection, for maintenance purposes, for inspection, you can use the crankcase doors. Next, we have the explosion relief valve. So the explosion relief valve, if there is overpressure inside the crankcase, or explosion maybe, or overpressure, so the spring will be overcome and the pressure will be released in the explosion relief valve. So there is a protection here, so that if there is any explosion, so the person outside will not be in danger. Okay, we also have crankcase oil mist detector. So crankcase oil mist detector, they have a fan, a lamp, and then we have a mirror and a measuring tube. So in this, the crankcase oil mist detector will suck mist or suck the air inside the crankcase, and then it will go through this tube, reference tube, and go to the fan, and then go outside, extraction fan. So if the reference tube, if you the lens can check whether there will be oil mist in the air sample that will be extracted. So if there are oil mist at a set point, different set point 2.5% LEL or lower explosive limit, so the crankcase oil mist detector will detect oil mist, and then it will give signal to everyone, or to give an alarm or signal that there is a possibility of explosion. So to prevent explosion, so maybe the engine will slow down, or depending if it has a higher measurement, so the engine might shut down or slow down. Okay, so the crankcase oil mist detector uses light sensor. So there is a light source, and then if the light will be scattered, so there are oil mist in the air. But if there is no oil mist, so the light source will go directly to the other side without reflecting it to the detector. Okay, next we have the electronic cylinder lubricator. So this is used to lubricate our liner and piston. So this is electronically driven. We have also manual driven cylinder lubricator, or mechanically driven. But the electronic cylinder lubricator lubrication is better, 50% less lube oil consumption, and more protection to the moving parts. Here we have the piston. So the parts of the piston, we have here the piston head, this is the crown, the piston skirt. This is for 4-stroke engine, so the piston skirt is long skirt. We have here the compression rings, and the oil ring or oil scraper ring, compression rings, or compression rings. We have the pin in here, the piston pin, so or snap pin, and then or wrist pin, and then we have a lock ring here, so snap pin to prevent the piston pin from sliding out. We have here the connecting rod and the bearings, connecting rod cap. Okay, next we have here the crankshaft. So we have the vibration damper on this end, and we have here the flywheel on this end. We have the connecting rod journal, and then we have the main bearing journal. We have here the counterweight for 4-stroke engine. And then this is a vibration damper. So there is a banded rubber inside. The high frequency movement resulting from twisting and untwisting of the crankshaft is called harmonic vibration. So each piston and rod assembly can exert over a ton of downward force on its journal. So this can actually flex the crank throws in relation to each other. If you do not control the vibration, serious damage can occur. So a vibration damper or harmonic balancer is used to control these vibrations. The damper also cuts load variation, the engine timing belt, chain, or gear, so they last longer. So the vibration damper is a heavy wheel mounted on a rubber ring to control harmonic vibration. So it consists of 2 metal rings. So this one, 2 metal rings, the outer inertia ring. This one is the outer inertia ring, and the inner sleeve, separated by a ring of rubber. So this is the ring of rubber, and this is the sleeve, this one inside, the gray one. So the balancer is keyed to the crankshaft snout. This makes the damper spin with the crankshaft. So here is the flywheel, stores energy from the power strokes and smoothly delivers it to the drivetrain of the vehicle between the engine and the transmission. So it releases balances this energy between the power impulses, assuring fewer fluctuation in speed and smoother engine operation. Okay, let's try to answer this one. So, in the engine industry, one still often speaks in terms of revolutions per minute. So, while in today's technological industry, one indicates the maximum permissible operational speed by means of frequency. So, how can we divide engines by speed? So, that is letter A. Letter B, name the parts of the 4-stroke engine from 1 to 22 in the picture below, or picture in the side. And letter C, explain the functions of 2, 3, 13, 18, 2, 3, 13, and 18. Okay, so let's go. So in the engine industry, low speed diesel engine, so the maximum, which has a maximum of 240 RPM or 4 revolution per second, while for medium speed diesel engine, it is usually rated at 240 to 960 RPM or 4 to 16 RPS or 4 to 16 Hertz. While high speed diesel engine have speed of more than 960 RPM or 16 Hertz. Okay, let's go with the parts. So number 1 is the sump tank. So number 2 is the counterweight. Number 3 is the explosion relief valve. Number 4 is the crank web. 5 is the crank pin. 6 is the engine block. This one, since this is a 4-stroke engine, so we call this as an engine block, or the crankcase. And then number 7 is the crankcase cover or crankcase door. 8 is for connecting rod. 9 is air receiver. 10, so in air receiver, the air from the turbocharger goes in here. 10, this is the liner, cylinder liner. 11 is the piston pin, 12 is the piston, and 13 are the piston rings or compression rings. 14 is the camshaft, 15 is the cam, 16 is the push rod, it pushes the push rod, the rocker arm. 17 is the high pressure fuel pump, 18 is the fuel rack, 19 is the rocker arm, this one. 20 is the exhaust, so since it is colored red, it's exhaust valve. And 21 is the inlet valve or intake valve. And number 22 is the cylinder head as a whole. So what are the functions? So number 2, the counterweight is used as a flywheel to balance forces, especially for compression. Number 3, the explosion relief valve is used to release pressure in the crankcase to avoid explosion. Number 13, the piston rings are protected for passing combustion in the crankcase. While number 18, fuel rack is used for changing the amount of fuel. By this, it regulates the speed of diesel engine. So the fuel rack is connected to our governor. Okay. Next, here we have the 2-stroke engine. So questions, name the parts of the 2-stroke engine from 1 to 20 in the picture below. Explain the functions of 2, 7, 11, and 12. And describe the working principle of 15 and 17. Okay, so let's answer. Number 1 is the sump tank. Number 2 is the bed plate. 3 is the crankshaft. 4 is the crank web. 5 is the crank pin. 6, this one is the A-frame or the frame. 7, here we have the crosshead guides. 8 is the connecting rod. 9 is the guide shoes or slippers. or guide slippers or guide shoes. 10 is the crosshead here. 11 is the crank explosion relief valve, and 12 is the crankcase door. 13 is the air cooler. 14 is the air receiver or the scavenging space air receiver. 15 is the turbocharger. 16 is the exhaust manifold. 17 here at the center is the exhaust valve. 17. 18 here is the elastic ball. It holds the cylinder head to the entablature. And the 19 is the high pressure hydraulic oil lines. So this one pushes the exhaust valve, or opens the exhaust valve, or closes the exhaust valve. And the number 20 is the piston with the piston rings. Okay, so the functions of 2, 7, 11, 12. So 2 is the bed plate. It is the foundation on which the engine is built. It must be rigid enough to support the rest of the engine and hold the crankshaft which sits on the bearing. Number 7 is the crosshead guides, used to direct a piston rod vertically. Number 11 is the explosion relief valve, is used to release pressure in the crankcase to avoid explosion. Number 12 is the crankcase door, needs when you want to check a condition of the crankshaft and make crankshaft deflection for visual inspection also, and for maintenance. 15 is the turbocharger. It works by exhaust gases which pass from exhaust manifold to the turbine wheel, which is connected with compressor wheel through the shaft. So the turbine wheel starts to rotate, hence the compressor wheel which sucks an air from outside and compresses it. Number 17 is the exhaust valve, works by high pressure hydraulic oil, so it pushes on the top of the valve which goes downward by this opens and allows the escaping of exhaust gases. So we have another picture. So in the picture below is a complete high pressure fuel injection system. Name the parts from 1 to 10. So number 1 is the cam, fuel cam. Number 2 is the cam rollers. 3 is the cam roll guides or cam roller guides. Number 4 is the plunger. 5 is the fuel pump, is the housing or the fuel pump assembly as a whole, fuel pump complete. 6 is the fuel rack, so this rack is connected to the governor. Number 7 is the lubrication oil supply to the cam roll guides, so that these cam roll guides will be lubricated, prevent damage. 8 is the fuel pump suction line, suction. And 9 is the fuel high pressure line. And number 10 is the fuel injector or injector. So explain the working principle of this system. So the fuel cam is rotated by the crankshaft. So it is either gear driven or chain driven. And then let's say it rotates clockwise, and when it reaches the top dead center, it pushes the cam roller up. So the cam roller goes up, and through the cam roller guides, reciprocating motion is transferred to the plunger, number 4, which also gives up and creates a high pressure fuel. Goes up and creates high pressure fuel. So the fuel inside the fuel pump will be injected. The high pressure fuel passes to the high pressure line and then to the injector. So when the pressure of the fuel in the injector is enough to lift the needle inside, so inside this injector we have a needle, injection, if the needle lifts up, then the injection happens. So the amount of fuel we can regulate by the fuel rack, number 6, which rotates our plunger or barrel. So which rotates our barrel or plunger, right? Plunger. It rotates our plunger. So that is the working principle of this system. Okay, so that's it. Thank you. So that's it for the parts of the engine. um, uh, there are still many parts of the engine that we haven't discussed, but these are the basic parts. So thank you for watching our video, and I hope I can see you on our next video. And please do subscribe and share our video to your friends, classmates, or so. Thank you, and see you on the next video.